What might only be a foot or two in the open ocean can become a 30-foot wave in shallower water at the coast. This single, chilling sentence comes not from a disaster movie script, but from an oceanographer at NASA's Jet Propulsion Laboratory. It perfectly captures a terrifying truth about the planet we live on, where a seemingly harmless ripple in the vastness of the sea holds the latent potential for catastrophic destruction. And this is no hypothetical scenario. This is the stark reality of what unfolded in late July, when the sixth biggest earthquake in recorded history tore through the Earth's crust off the coast of Russia's remote and rugged Kamchatka Peninsula. A colossal magnitude 8.8 quake, a seismic event of almost unimaginable power, unleashed a silent, speeding monster across the entire Pacific Ocean, a tsunami. Today, we are pulling back the curtain on this incredible global event. We will witness the awesome power of this wave through the electronic eyes of a revolutionary new satellite. We will explore the terrifying physics that transform a small swell into a coastal destroyer. And most importantly, we will discover how this very disaster is now arming humanity with the tools to better predict and therefore survive the next one. This is the story of a cataclysm, a guardian in the sky, and a scientific breakthrough born from the very heart of chaos. To truly grasp the scale of this event, we must first journey deep beneath the waves to the moment of its violent birth. A magnitude 8.8 earthquake is something that defies easy comparison. The Richter scale, as many of us know, is logarithmic. This means that for each whole number you ascend, the ground shaking increases by a factor of 10, but the raw energy released multiplies by more than 30. An 8.8 event isn't just a little stronger than the quakes that make the news. It releases hundreds, even thousands of times more energy than a powerful city-leveling earthquake, an energy release equivalent to tens of thousands of atomic bombs. This wasn't a tremor. It was a fundamental, violent reshaping of our planet's surface, hidden beneath miles of water. The location is key. The Kamchatka Peninsula, a vast, desolate landscape of towering volcanoes and pristine wilderness, is a critical part of the Pacific's infamous Ring of Fire. This geologically active belt, stretching in a 250,000-mile arc around the Pacific Ocean, is where the majority of the world's earthquakes and volcanic eruptions occur. It's where the colossal tectonic plates that make up Earth's crust grind against each other in a slow-motion, eons-long dance. But sometimes the pressure becomes too much. A section of one plate, stuck for decades or centuries, suddenly slips, lurching forward in a matter of seconds. In this case, a titanic section of the seafloor was violently and instantly thrust upwards, displacing a truly staggering volume of ocean water. Picture the entire water column, a continuous mass of water from the dark, crushing pressure of the seabed all the way to the sunlit surface, being heaved upwards in a single, unified motion. This is the birth of a tsunami. It's a completely different beast from the waves you see at the beach, which are merely surface-level disturbances caused by wind. This is the entire ocean itself, moving as one, carrying the raw, untamed energy of the earthquake within its very essence. As this invisible pulse of energy began its silent, deadly race across the Pacific, traveling at the astonishing speed of a commercial jetliner, something was watching. High above the atmosphere, orbiting in the cold vacuum of space, a technological marvel was in the perfect position at the perfect time to bear witness to this planetary event. This technological marvel is the Surface Water and Ocean Topography Satellite, known simply as SWOT. Think of it as humanity's most advanced eye in the sky, a silent sentinel dedicated to understanding the lifeblood of our planet, its water. SWOT is not just another satellite. It's the result of a monumental international collaboration, a groundbreaking joint mission between the United States NASA and the French space agency, CNS, the Centre National d'Études Spatiales. This partnership brings together some of the world's greatest minds in engineering and oceanography. What makes SWOT so revolutionary is its use of a cutting-edge technology called Ka-band radar interferometry. In simple terms, it sends down a pair of radar signals and meticulously measures the tiny, microscopic differences in the time it takes for them to bounce back from the water's surface. This allows it to create three-dimensional maps of the ocean's surface with a precision down to the centimeter. Its primary mission is to conduct the first-ever global survey of all of Earth's water, from the mightiest rivers and largest lakes to the vast open oceans, charting their rise and fall with an unprecedented level of detail and accuracy. But on this fateful day in late July, its routine mission of mapping the calm heartbeat of the planet was interrupted. It found itself tracking something far more urgent, something wild and untamed, the fleeting, destructive pulse of a tsunami, a phenomenon that few instruments have ever been able to capture with such clarity. Approximately 70 minutes after the earth-shattering quake had shuddered through the planet's crust, SWOT's sophisticated radar altimeter instruments locked on to the tsunami's leading edge. The data it collected was nothing short of breathtaking. NASA's Earth Observatory later processed this information into a stunning animated graphic, a visual representation of the invisible wave. In the animation, you can see the wave propagating outwards from the epicenter in a near-perfect arc of energy. The darkest red spots on the map highlight where the water level of the open ocean had risen by more than 1.5 feet, or 0.45 meters. Now, your first instinct might be to think, 1.5 feet? That doesn't sound very scary. I've seen much bigger waves just from a passing boat. And this is precisely where we must return to that chilling, counterintuitive statement from Ben Hamilton, the NASA oceanographer. A 1.5-foot tall wave might not seem like much, but tsunamis are waves that extend from the seafloor to the ocean's surface, he explained in a NASA release. This is the critical and often misunderstood difference. When that colossal column of water, displaced by the underwater earthquake, travels through the deep ocean, its immense energy is distributed throughout a massive volume of water, thousands of feet deep. Therefore, on the surface, the change in height is minimal, almost imperceptible. You could be on a cruise ship in the middle of the Pacific, and a powerful tsunami could pass directly beneath you, and you might not feel so much as a gentle bump. The true danger is hidden. But as this wave, this colossal body of energized water, approaches a coastline, a dramatic transformation begins. The seafloor begins to rise, getting shallower and shallower. The energy that was once spread out over thousands of feet of water depth is suddenly and rapidly compressed into just a few hundred feet, then just tens of feet. All of that immense pent-up power has to go somewhere, and it goes up. The wave's speed decreases, but its height grows monstrously, exponentially. That 1.5-foot ripple in the deep ocean becomes a 10-foot wall of water, then 20 feet, then, as Hamilton warned, a horrifying 30-foot wave. And it's not a curling, breaking wave like a surfer would ride. It's a surging, unstoppable flood, a battering ram made of the ocean itself, capable of bulldozing everything in its path. It's a truly chilling transformation of energy into matter. If you're finding this deep dive into the raw power of our planet as fascinating as we do, please take a quick moment to hit that like button. It truly helps us understand what kind of in-depth stories you want to see more of. In this particular instance, the tsunami triggered by the magnitude 8.8 quake was, surprisingly, less powerful than some scientists might have initially expected for such a massive seismic event. But the term less powerful is dangerously relative when dealing with forces of this magnitude. For the coastal towns in Kamchatka, located perilously close to the quake's epicenter, the reality was still utterly terrifying. Waves reaching heights of up to 13 feet, or 4 meters, came barreling into shore. In one incredible piece of citizen footage that later emerged, a person simply walking their dog along coastal cliffs captured the moment the massive swell arrived. The video shows not a crashing wave, but a dramatic and rapid surge of the sea itself, the water level rising unnaturally fast, a visible and potent reminder of the immense forces at play just offshore. The warnings, however, had gone out across the entire Pacific basin. In places thousands of miles away, like the United States West Coast, Hawaii, and Japan, emergency services were on high alert. Sirens blared in some coastal communities, and evacuation orders were issued in low-lying areas. For hours, a tense quiet fell over these regions, a period of anxious waiting and watching as people tuned into news reports, their eyes fixed on the horizon. Thankfully, as the wave traveled its vast journey across the ocean, its energy began to spread out and dissipate. By the time it reached these distant shores, it had diminished to a much smaller, less threatening size. The tsunami warnings were soon downgraded to advisories and then lifted entirely. A global catastrophe had been averted. But the wealth of data gathered during those tense hours of uncertainty was about to become absolutely priceless for the future of humanity. This is where the story pivots dramatically, from one of potential disaster to one of groundbreaking, life-saving science. The unique and detailed data collected by the SWOT satellite wasn't just a fascinating picture of a rare natural phenomenon. It was a golden ticket, a treasure trove for the scientists at NOAA's Center for Tsunami Research. The primary job of these dedicated researchers is to create, maintain, and run the sophisticated forecast models that predict how a tsunami will travel across the ocean, and most critically, how big it will be when it makes landfall at any given coast. These complex models are the very backbone of our global tsunami warning system. They are what allow authorities to issue timely, accurate alerts and save countless lives. But any computer model, no matter how advanced, is only as good as the data it's built upon. Traditionally, these models have relied on seismic data from the earthquake itself and readings from a sparse network of deep ocean buoys. These buoys are incredibly valuable, but there are only a limited number of them, like a few lonely sentinels in a vast empty desert. They provide crucial data, but only at specific points. As Josh Willis, another oceanographer at NASA's Jet Propulsion Laboratory, pointed out, the satellite observations are a complete game-changer. SWOT provides a continuous, high-resolution picture of the wave over a vast area, filling in all the massive gaps between the buoys. This allows researchers to better reverse engineer the cause of the tsunami, to use the exact shape and size of the wave to understand precisely how the seafloor moved during the quake. In this specific case, he noted, the data also provided a crucial and immediate validation of current methods. It also showed us that NOAA's tsunami forecast was right on the money. This was a massive vote of confidence in the existing system, but it gets even better. The real, paradigm-shifting excitement came when the Center for Tsunami Research took SWOT's pristine, high-resolution data and fed it back into their forecast model, testing to see if it could improve future predictions. The results, according to the center's chief scientist, Vasily Titov, were absolutely incredible. In the NASA release, he expressed his excitement, stating, "It suggests SWOT data could significantly enhance operational tsunami forecasts." This isn't just a minor improvement, it's a monumental leap forward. Imagine being able to predict, with even greater accuracy and confidence, the height, shape, direction, and arrival time of a destructive wave. It means more precise warnings, fewer unnecessary and costly evacuations, and most importantly, a much better chance of survival for every single person in the tsunami's path. We are literally watching a new era of disaster prediction being born from the data of a single event. This is how science brilliantly turns a near disaster into a powerful lesson that can save countless lives in the future. It's a powerful reminder of why this kind of research is so vital, and if you want to stay informed about the incredible breakthroughs that are making our world a safer place, make sure you're subscribed to the channel and have those notifications turned on. In conclusion, the epic Russian earthquake of late July was a stark and humbling reminder of the immense, untamable power lurking just beneath the surface of our seemingly placid planet. It unleashed a force capable of crossing the largest ocean on Earth in a matter of hours. But at the same time, this event showcased humanity's rapidly growing ability to observe, understand, and ultimately predict these terrifying natural phenomena. Thanks to the watchful eye of the SWOT satellite and the brilliant, collaborative minds at NASA, CNES, and NOAA, a wave of potential destruction has been transformed into a wave of invaluable knowledge. The data captured in those crucial 70 minutes, high above the churning Pacific, will ripple through the scientific community for years to come, strengthening our defenses, refining our understanding, and making our coastal communities safer. While we can never stop the Earth from shaking or the oceans from rising, we are getting better and better at seeing what comes next, turning fear into foresight, and transmuting chaos into a clear blueprint for survival.